are the methods for structural health monitoring of residential and commercial structures in India? And
Yes.
this question is of two parts. Like when we deal about energy saving opportunities in buildings, so for example, renewable energy integration for lights or HVAC and all that. How are we assessing or how are we evaluating?
Previously, if you see we used to go to the typical building or a bridge, okay, check its, take samples there, do the visual inspection, okay, and then comment on its repair tactics, right? These days, there are a lot of concrete which are having this self-sensing ability. I'm talking about a concrete which is futuristic. Okay, so I'll come to the point what is structural health monitoring, but because this slide was open, I'm just talking about that. So these days, in future, okay, we will be working with the concrete which are self-sensing. They are able to transmit the electrical signal from that, and because of that, okay, remotely, as you can see, this lady sitting remotely from a bridge, okay, she is able to get the signals from the bridge. So this is how now we have recently seen a lot of bridges have been collapsed, okay, during construction and maybe after the construction. uh, Imagine a case wherein some sensors are installed, okay, and remotely we are able to check the signals coming from those sensors, okay. This we call it as structural health monitoring, okay. I would go back to the concept of structural health monitoring, like structural engineers will be having the role of similar to doctors, okay. When we go to the doctor when we are ill, okay, doctor will actually check us, okay, through various methodologies. He'll check our pulse, okay, he'll check our heart rate, he'll take the blood sample, okay, and maybe we have to go to the CT scan, right? Similarly, as a structural engineer or as a civil engineer, okay, we have to utilize tests like rebound hammer, ultrasonic pulse velocity, and in case we may have to take a core, okay, like the way the doctor take our blood sample, we may have to take a core from the existing structure, and uh, we may utilize acoustic emission, like as I was mentioning about hammer. The way doctor is using hammer, we are using rebound hammer, okay. He is checking the pulse, okay. We may have the ultrasonic pulse velocity test, okay. He is taking blood sample, we can take the core, concrete core, right? So for doctor, patient is the a human being, and for us civil engineers, the patient is our structures, okay. So I was talking about the ECG what doctors take, okay, to check whether we are going to have the heart attack or we had that symptoms or not. Similarly, there is a technique called acoustic emission, in which I did considerable work during my PhD at Indian Institute of Science, Bangalore. And as you can see, these are the sensors which are kept on the structure and remotely. And not only those, I mean, any kind, maybe the ship or maybe aircraft or any structure, okay, or it may be a huge tank or a pipeline. Sensors can be kept there, and its signal will tell us, okay, whether there are any cracks in it, initiating cracks or not. See, we come to know only when the structure has failed, right? But while the structure is undergoing cracking, is there any technology? Yes, there is, okay. So acoustic emission is one of that, and which can be utilized to even see the if there is a crack or if any I would say damage is there. Okay, one of the bridge I was able to actually monitor. As you can see, this is one of the bridge being monitored. Uh, I would just like to show just 1 minute. Uh, just 1 minute. So I think this is what is structural health monitoring. Okay, keeping some sensors on the structure and getting the signals remotely, or maybe some instrumentation kept there that will tell us the indication before the structure is getting failed or damaged. So this is how called as a structural health monitoring. And the second part is a trend of research towards energy efficient building, okay, and net zero okay, building. So to these days, the entire world is working on how we can, minimize the energy being utilized in a building. Let's say if we are using a air conditioner, there are a lot of vertical farming and other aspects are there. Maybe the architects, they know better that even they design the building the way the sun move from east to west. Okay, so the entire orientation, there are a lot of parameters to be seen as an architect to design a building. I've seen those books, wonderful books, wherein the sunlight, I would say sunshade, and the orientation of doors, windows, to make sure that maximum sunlight, daylight is there in the building, so that you need not switch on the lights during the daytime. At the same time, a lot of these days, a lot of vertical farming is there, okay, on the wall, so that it will make your walls cool, and hence your the load on the air conditioner will be less, or it may be a case wherein you don't require air conditioner, right? And at the third point is the usage of water. Okay, how minimum, like the tap water what we use. Okay, these is a lot of taps are there wherein it will have so many tiny particles, so you need not utilize, I mean, that will be a saving of almost 70 to 80% of water. So these are the typical parameters, I would say, which will lead to energy efficient building and net zero building, right? These are my.
I think structural integrity is one of the toughest things to retrofit or achieve through retrofitting. So can you just walk us through the retrofitting methods for restoring the structural integrity of old buildings, and how difficult it is, or what are the challenges when we deal with this aspect?
Sure, okay. So while I speak about this, I think Dr. Santosh has covered quite a major part of how the whole process actually starts. Okay, so like whenever you try to go visit to a doctor, the doctor always asks you a set of questions to understand what is the problem statement. And to understand this problem statement, we actually do a lot of understand the scope. We do a lot of activities on the job site. So like initially starting to this, we perform test like hammer test, you perform the pulse test, you perform the core test. And then you, with all of these kind of test parameters, you are able to understand that how my what is the strength is it is there in my building, and what is the additional that we have to do. So basically the retrofitting actually happens when the building is not able to bear the loads, or there is a function change in the building. So maybe an extra load is going to come, or maybe the structure has gotten weak over the course of time. To perform this, there are various technologies in the market. So the first technology is reinforced concrete jacketing. So again, this happens through chemical anchors. So you put a rebar around the, if you have to reinforce jacket a column, then you make the designs, you understand what diameter of rebars have to be utilized, what should be the embedment depth of those rebars, and over that then you utilize chemical anchors. Then there's come the second technology, which is about introducing steel jacketing towards the your supporting elements, or your load bearing elements. So like steel jacketing of columns, steel jacketing of your beams, slabs. So this is again, so this can happen with both chemical anchors, and it can happen with mechanical anchors as well. Then there's a third kind of a technology, which is fiber reinforced polymers, which we also term as wraps. So these are the major three technologies which are there in the market to provide the right strength which is desired as per the function of the building. Now, looking towards the difficulty, yes, it is not an easy process. This is a very complex process and requires quite a lot of attention towards the complete cycle when we start from the qualifications, understanding the scope, then designing, and even also at the time of installation. Since what we see in drawings is not necessarily important that we see the similar situation on the job site, because every time when you see the practicality of executing what you have been designing, there are multiple challenges to it. So one of the biggest challenges, accessibility to the structures. Like if I'm able to have the access where I have to perform this job or not. So if I will not have the access, then it will be really, really difficult to actually perform what we are designing. So as a designer, yes, this things is difficult, but while executing the designing is even more difficult part to it. Then also a very complex thing is how old my building is, because treating old structures with requires quite a lot of care, and with that we also need to consider what kind of technology should be there in place. Parallel to this, I also have to consider third parameter, if while performing the job, what will be my building occupancy, because if we have to perform this in a building which is having an occupancy, this is a difficult task again, because you have to manage with not just the construction, but you also have to manage the external factors because of the occupants. There may be a shortage of electricity. There may be various clauses and safety parameters that you have to follow while performing the job. So these are the such kind of some of the common practices and the difficulties that you face on the job sites.
Okay, thank you. I think Mr. Shomendra is back, so I would like to go to his question. So, as we speak about waterproofing, how do you ensure that waterproofing materials chosen for retrofitting are compatible with the existing materials in the buildings?
So this is more of a commercial and logistics decision because the liquid applied polyurethanes hybrids, they bond very well with practically every existing material which is there on the roof, especially with the use of a good primer. So you can actually go ahead and apply the waterproofing on whatever was there earlier. But if we get that back to sound surface, like the base concrete, that is always a better solution. Sometimes due to logistics, or maybe the say like if you're doing an industrial building, the roof and they cannot shut the production, then they would rather go ahead with the applied membrane on the existing waterproofing without any disruption. Or if in a building we have to excavate and remove a lot of brickwork or the existing applied products, then we are forced to apply the coating on top of the existing waterproofing. Of course, it works the best if you bring it down to the sound basic base concrete. But then again, it can be applied both. It just depends on the situation where which the client wants to go for. If he has enough time, or if the cost permit, then we would rather do it on the core or the base material.
So, Architect Kush, do you have, you have any other inputs on this question you can share, or we can move to your question?
Basically, we're not clearly, directly affiliated with the field in that sense. We're dependent on our MEPF consultants who basically go to experts whenever there is a problem. And, but there was a question that you asked about energy saving and sustainability, so that is something, you see, the term sustainability is everywhere today, and it's often misused, but nevertheless, it is especially important, very important for the stakeholders of the built environment to truly understand sustainability as more than a keyword and understand how they can implement it in their work. Uh, Smart living and innovative designs follow sustainability. In fact, if you look over if I look over a span of 35 years, I see that buildings in the past, where we used to inherently uh, implement passive energy saving measures, passive cooling measures, were far more sustainable than the present day buildings, which are made in glass and steel and allow huge amounts of sunlight. And then, you see, uh, earlier we had, very simple methods. One was like one of our colleagues earlier mentioned, the orientation of the building, which played a critical role. The ventilation, basically wind flow through the building, which played a critical role. Uh, Elements like cavity walls, which played a critical role to ensure that heat, because bulk of India is a hot and dry place, that heat transmission is prevented. So all these measures, along with things like wind towers and all, which brought in wind into the buildings, into the traditional built forms. Uh, you see, all these played a key role, and they helped in providing an environment which was naturally cooled or naturally heated. Whereas today we are largely dependent on artificial means of cooling, artificial means of stopping heat. Like, fine, I mean, even we do commercial buildings which have glass facades and all, then we end up using low emissivity glass, argon filled glass, double glazed panels to minimize heat flows. But what if we did not use that glass? That is the question. What if we went back to some of our old traditional methods and drew from them? Because they they were definitely far more energy efficient than the present day techniques. So that's all. That's all I want to add.
I would like to add a couple of things, if I may.
Sure, sir.
Okay, so now the CII has a great program in which they have a green certification for products as well as companies. So we have gone through that, and I'm happy to report that not only all our products are CII green certified, so they have a bio content based. They calculate the amount of energy which you are using, no, and so there's a lot of complex calculations, and you can arrive at how sustainable your company or your products are. So that's one, and including the GHG emissions, how much energy you need use to make your products, whether you are using bio-based raw materials, all of that goes into the assessment. But also adding on the aliphatic top coat, which I was speaking about earlier, that is a very good and way of passively reducing the heat load of the building. So if you are reflecting a major portion of your incoming solar radiation, then all your the air conditioning costs are going down, and these can be now practically calculated and demonstrated as well. There are some consultants who will take the design of your building, your location, which side it is facing, and all that thing, and they can actually work and let you know how much energy you will reduce, energy consumption you will reduce by adopting a reflective surface on the roof. So like a emissive product. So those calculations are very real. We are working with some major customers the Mercedes plant down south. It's a huge facility. They are going for LEED certification. And one of the products which they are using now is the aliphatic heat reflective coatings on the roof. So the coatings also do contribute to the heat load of the building.
Okay, great. So I have some common questions. So one common question that I had is like, as far as India is concerned for retrofitting, and especially for residential retrofitting, like because that's where the major chunk is. So what do you think are the regulations and standards which are prevalent in India, or as builders or as citizens? Like, how are they? What are they supposed to be aware of when they go in for retrofitting? So it's an open question. Anybody can answer, and I really want everyone to contribute.
If you look into the design perspective requirement as for the Indian standards, the Bible for doing construction in India is NBC 2016, and then parallel to this, there have been different codes which comes in place. So like when you have been speaking about seismic designs, so majorly before this new standard which has been published by BIS, we used to follow different European standards because this I'm particularly speaking about post-installed anchoring technologies. So if you look into those specific requirements, then there was earlier different design methods like TR045, TR029. There have been different codes, ETEC 001, but now everything has been summarized for post-installed anchoring technologies in EC2 if you have to follow the European standards. Now, India, there's an Indian standard which have come in place, 1946. So it has very recently launched, and we are going to just, depending upon different requirements from structural consultants, we can look into the scope of this design methodology as well, as it is also suitable for designing for both chemical and mechanical anchors.
Mr. Dheeraj has, I think given the answer. And as far as codes are concerned, I think he mentioned a lot of codes. Actually, being an academician, I am more into the teaching of those. However, because this being a very specialized thing, code for the retrofitting, maybe I think the person who is really doing Mr. Dheeraj, he I think answered the question. So no comment from my end.
Okay, thank you so much. Okay, one question is like, what do you think is or what are the barriers to retrofitting in India? Like, even if people want to upgrade their buildings? This again is an open question. Anyone can answer.
When you have been speaking about that, what can be the challenges for this industry? So majorly, if you look into the current phase, like how our industry is actually growing, and there have been different technology introduction in the market. So earlier, when retrofitting technologies used to be just a concept, these things started somewhere around 35 years back in the Indian market, when people have been able to understand different scopes, like, oh, okay, these kind of technologies also are also there in the market. Before that, people, if there has to be any corrections to be made, or something new or some addition has to be done, it was not possible. Earlier, people have to break these structures and then reconstruct those structures back again. Now, this is something like with the introduction of post-installed anchors, chemicals, wraps, various other technologies. Now, these things have been, quite easy to do, and without doing the damage to the existing structure, and introducing the new technologies. Now, depending upon, like, is it a trend? So yes, this is something which is happening every day. Even this is not something about the old buildings. This is something which even happens in the new construction. Even while the construction, there are certain corrections that are required, or maybe while even during the construction, the architects decide the functionality of building is going to change. Maybe a building plan is going to change, the column location is going to change from one place to the other place. So these are some practical challenges in the under construction building. I'm not just speaking about a newly constructed or a heritage building. There's something about which is the buildings which are under construction as well. And looking as per the difficulties, so majorly the difficulty actually comes in place when you have to treat a very old structure, and looking into the scope that, as per the building functionality type, how much addition has to happen. Would that addition be sufficient enough or not? So for that, the first and foremost parameter is that everything should be clear from the scope point of view, and then the designing should happen as per the scope what is defined, because the forces should qualify in design. If the forces cannot qualify in design, then the next phase of installation cannot come in place. Now, these are similar, which I suppose I'm not the expert in waterproofing technologies. So as when you come in the retrofitting of structures, then definitely the waterproofing technologies also comes in place. So maybe I will hand it over to experts in waterproofing.
Some challenge in the sense, it's more of a commercial challenge, because a lot of people have moved into apartment blocks and condos and societies, and therein, even if there are leakages and stuff, it's really the AOA never gets together to find a real solution. They're constantly bickering and fighting. So it's more of a commercial challenge rather than a technical challenge.